Everyone, today I'm going to discuss about what are vector quantities and how to represent them mathematically on a piece of paper. So basically vector quantities are those physical quantities which are described not only with the magnitude. When I say magnitude, that means their size. Okay, so they are not only described by the sizes but also with the direction. Now let's say if I say that I am traveling in this direction with 10 kilometers per hour. Now I have specified my direction along with the speed. So speed with direction is given a name as velocity, and velocity is a vector quantity. Similarly, what if I say that I am going to apply force on my face in this direction? Now in that situation, this is the direction of force and the amount of force that I have applied is the magnitude of force. So force is again a vector quantity. Now what if I am applying force on myself from two directions, right? Like this. Let's say on this direction I am applying 10 newtons of force, while from the other direction I am applying 2 newtons of force. So the net force acting on me will be the resultant, or you can say sum of these two forces, right? In that situation, you simply add these two forces to check what type of force or what amount of force is acting on me. For that, you need special type of addition, and that is known as vector addition. So this is what I will be explaining. So now I'm going to tell you how to represent a vector. Now let's say this is a vector whose length is 1 meters and it starts from point O and ends at point A. Now the direction is, let's say, towards the east. Now this is the direction of this vector quantity. So this vector OA is represented as the magnitude of OA, and we represent magnitude of OA with this mod, and it is multiplied by the unit vector, and unit vector is something which actually tells us about the direction of the vector. So this is the representation of the vector, or another way of writing it is, let's say this is vector A. So vector A is written as magnitude of vector A multiplied by unit vector. So any vector quantity is represented in this manner. Now we will be talking about resolution of any vector quantity. Now over here, how to resolve a vector quantity is, like, let's say over here I have a vector A with whose projection on x-axis is ax and projection on y-axis is ay. This vector A is written as magnitude of this vector multiplied by the unit vector along x-axis plus the projection of this vector on y-axis, which is ay, multiplied by the unit vector along y-axis, which is j cap. So this is how you represent a vector quantity if you are able to resolve it on x-axis and y-axis. So basically this ax over here is x component of vector A, ay is y component of vector A. Now let's just talk about how to find the magnitude of any vector and its direction, right? Now, as I already told you, vector A is ax I cap plus ay j cap. To find the magnitude of this vector, what you will do is you take square root of ax squared plus ay squared, right? And to find the direction of this vector, which will be represented by this angle that it makes with the x-axis. So that is given as tangent theta equals to ay over ax. So from here you will be able to calculate the angle with the x-axis. So this will actually tell you in which direction the vector is with respect to x-axis. Okay, you can also find it out with respect to y-axis by finding this angle from here, and then you can subtract that angle from here that you get from here from 90 degree to get the angle with respect to y-axis. Now I'm going to tell you why the magnitude formula was as such. Now look here, over here, triangle OAB. In this triangle, this is 90 degree, and if this is AY, then AB is also AY. Now consider the triangle OAB, right? Now over here, you can apply Pythagoras theorem, which says OA square is nothing but OB squared plus AB squared, right? Now over here, OA squared is nothing but A squared. OB squared is AX squared plus AB squared is AY squared. So from here, magnitude of A comes out to be square root of AX squared plus AY squared. So this is why we actually calculate the magnitude of any vector if you know the X component and the Y component of that vector quantity. Now, to find this angle theta over here, which will tell you about the direction, if I consider this triangle OAB, in this triangle tangent theta is equals to, we call it as opposite over adjacent, or you can also say that it is perpendicular by base, right? So perpendicular is AY over AX. So from here to calculate theta, it is tangent inverse of AY by AX. So this theta angle will tell you the direction of vector quantity A. Now let's consider triangle OAB. Now in this triangle, what is the value of cos theta? Cos theta is nothing but we call it as adjacent over hypotenuse. So adjacent is AX over A. So from here AX comes out to be A cos theta. So this is how you represent the X component of any vector in terms of the magnitude of vector and cosine of the angle that that vector makes with the x-axis. Similarly, if I take out the value of sine theta from the same triangle OAB, it comes out to be AY over A. So AY from here comes out to be A sine theta, and that is how you represent the Y component of any vector. I hope you guys liked the video. Now don't forget to subscribe my channel for more updates.